as I mentioned, last day, while I discussed about this kind of dynamic model with discrete time, I mentioned a lot of things regarding B. Mod B less than 1, that indicates the time path will be convergent or equilibrium is stable. And mod B greater than 1 indicates the equilibrium is unstable. On the other hand, B positive, that indicates the time path is monotonic. B negative, that indicates the time path is oscillatory. Okay, so today I'll start with A. What is the role of A? Is it visible?
Yes.
Yes, ma'am.
Yes, ma'am.
Okay, so please look at the second part of this slide. Though I have used the notation capital A while I discussed yesterday's problem, I used the notation small a. So this capital A is equivalent to small a. Please consider this capital A as small a we used in our trial solution, a b to the power t. That A is there. Okay. So first, let's look at the points. A has two effects. The magnitude of A can serve to blow up or pare down the value of b to the power t. So the point is telling that if the value of A is greater than 1, in that case, it is a product. Trial solution is a product, A b to the power t. So whatever impact we are getting through b to the power t, that effect will be increased if A is greater than 1. If A is greater than 1, that effect will be magnified, that effect will be blown up. Okay. Alternatively, if A is less than 1, it's a positive fraction. In that case, or suppose we are considering the absolute value of A. So if the mod A value is less than 1, in that case, whatever impact b to the power t is bringing, that will be, reduced a bit. Okay? So A can blow up the effect of b to the power t. A can reduce the impact of b to the power t. So this is number one. Second, the sign of A, on the other hand, affect the shape of the path. If A is less than 0, each time path will show its mirror effect with respect to horizontal axis compared to the cases where A greater than 0. Now, what is the meaning of this thing? Okay, so to understand that, just look at this diagram. So if A is greater than 0, we will start from this point. And if A is less than 0, we will start from this point. So the second diagram is the mirror image of the first diagram. So if the starting value is negative, we will start from this point. And if the starting value is positive, we will start from the other part. Same thing will happen if I consider the oscillation. Here, I have started from this P naught. It can be started from this level too, and you can have the same result. Or for these two, I have started from this point. However, you can first start from this side and then the similar kind of oscillations you can draw. So if A is positive, you will start from this part. Your starting point will be like this. And if A is negative, you will start from this part. Otherwise, the basic idea, everything will remain unchanged because everything will be determined by B, not by A. whether it will be oscillatory, whether it will be monotonic, whether it will be monotonic convergent, monotonic divergent, oscillatory convergent, oscillatory divergent, etc. Everything will be determined by B. However, A also has two important roles. It can change the scale of impact of B to the power T. It can increase it, it can reduce it. And the second thing is it determines the starting position, whether we will start from the positive side or whether we will start from the negative side. So these are the two very important roles that the first component A plays in the trial solution A b to the power T. Any question? Any question?
Ma'am, in cases of mirror images, the increasing and decreasing is switched, right? So one is increasing and other becomes decreasing, but both are convergent.
It can be convergent, it can be divergent, it can be anything. However, the starting point will differ. If A is positive, let me do the thing this way. Okay. So let me construct a new page. So I'm talking about time path. If A is positive, suppose you are considering oscillatory divergent, that means explosive oscillations. So this kind of case we will consider. Like this. So this thing, okay? In the first case, A is positive. In the second case, A is negative. And if you match the two things, you will find that one is mirror image to other. Okay, so here we are considering oscillatory divergent or explosive oscillation. A similar thing can happen for convergent and oscillatory. That means if you consider damped oscillation, you will get the mirror image. If you consider the monotonic path, in that case also you will get the mirror image. So let me do one case for monotonic divergent. Okay. I am now drawing the case when A is positive. Okay. Next, I am considering the case monotonic divergent. A is negative and we are getting the reflection of the first case. Is it now clear? Or should I need to draw more diagrams?
No, ma'am, it is clear. Thank you.
It's clear? Very good.
Ma'am,
Yes.
so the magnitude of A, since it's just producing a scale effect and it's not changing the basic time path, it doesn't really have a major significance economically, right?
B really plays more important role. However, we cannot say that A has no role. Actually, here we are considering a time-based analysis. So off equilibrium starting position is also important. A is not changing the idea of the nature of the time path. However, the starting point is also important, whether historically I was in this position, a country was in this position, or historically country was in that position. So starting from 1985, say, when or say starting from 1990s, when the new economic policy, trade policies, all these things are coming. Okay, so starting from 1990, if I want to look at the trend, whether starting from the smaller level the explosion has started, or starting from a positive level the explosion has started, this is also important, because we want to have the entire picture. Now we are learning the things, we are making zigzag because we don't have any database. However, all these concepts are heavily used in empirical analysis, which we call the time series analysis. Okay, so when we really plot a time series, really we want to understand the ups and downs of the time series. Starting point is also important. Okay, so it's better not to compare all these things in that way. That is, we don't need to understand the role of a while we are going for economic analysis. It is not so. However, to understand the nature of the time path, whether it will be convergent, divergent, explosive oscillations, damped oscillations, monotonic convergent, monotonic divergent, B plays the role. That's the answer to your question.
Yes, ma'am. Yes. So the starting point is important, and that's why A has a major role, and that is given by the sign of A.
Yeah, and when you will go for economic analysis or the time series analysis, if there is something which is pushing up B to the power T, or, pushing down B to the power T, everything is important, isn't it?
Yes, understand.
B is determining the nature of the time path, okay? Or however, whether it will be a bit blown up, whether it will be a bit reduced, these are determined by A. So A has also important role. And when we will start application, you will find that A is basically, last day also we got that thing, but clearly maybe we could not show it. However, when we will start doing all these applications, you will find that A is nothing but P naught minus PE, or Y naught minus YE. This kind of concept, that is how the starting point deviated from the equilibrium position. Okay, so together the entire thing is producing the entire picture of the time path. So all the components are important. Any other question? Okay, so by the time, I hope everybody got this diagram from Chiang. What are the possibilities? Last day, we also discussed some of the possibilities. Even today, we discussed some of the possibilities, However, this is a very good diagram of different possible varieties of time path from Chiang. So everybody got this in Chiang? You checked Chiang?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Only 2, 3, 4 voices, only 4 people checked. There are some other voices who checked it.
Ma'am, I checked too.
Yes, ma'am, we checked.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes,
So
ma'am.
at least 15, 16 people checked. Okay, fantastic. So everybody needs to check this thing. Everybody needs to check this thing, okay? So you will find that here they are breaking the zones, between 0 to minus 1, 0 to plus 1, 0 to minus 1, beyond plus 1, beyond minus 1. So did the thing in this way. Now, if you consider the positive zone, B value is positive, you will get the monotonic time path. If you consider 0, actually it is merging with the axis. Today, Rona
Ma'am,
said,
can you just maximize, like, make the screen bigger? I cannot see.
is it better now?
Yes, ma'am, I can see.
Okay. Okay, so, it can be 0 even. If it is 0, your time path is merging with the axis. If the value is 0, the time path is merging with the axis. Okay, so this is one possibility. However, generally we do not get the value to be 0 or 1. Again, if the value is equal to 1, okay, in that case it will give us this kind of value. So as long as between 0 to plus 1, in fact, when it is positive, we will get monotonic time path. If B is positive, you will get monotonic time path. And if B is negative, you are getting oscillatory time path. So this is the first difference. So if you look at the diagrams which are above 0, you are getting monotonic time path. And if you look at the diagrams which are below 0, you are getting oscillatory time path. Then the question is whether the value is less than 1 or not. Mod values are less than 1 or not. If in both the sides mod values are less than 1, that is in positive case it is in between 0 and plus 1, you are getting convergent time path. And if you look with the value between minus 1 and 0, then also you are getting convergent time path. When positive, convergent and monotonic. When negative, convergent and oscillatory. Okay, so you are getting damped oscillations. When the B value is minus 1, you are getting uniform oscillation. When the B value is actually mod B value is greater than 1, so it is crossing the minus 1 limit. In that case, you are getting explosive oscillations. You are getting explosive oscillations. In the similar fashion, here convergent at 1, a straight line, and when the value of B is moving beyond plus 1, in that case, you are getting divergent time path. So these are all possible varieties of the time path we can derive using the first order difference equation. Okay, so it is giving us a lot, all possible varieties of time path. Okay, however, the time is discrete. So whenever you are drawing something or understanding the issue of time, remember that between two time points, whatever path you are considering, that remains unchanged. That does not change between 1 and 2 or between 2 and 3. Only coming at the juncture, you will have a state, you will have a change. Okay, so this is also important. So keeping these concepts in our mind, in the next step, we will move to several applications of first order difference equation in economics. Today, we will try to discuss the cobweb model. Cobweb model, okay? Cobweb model is a very famous application of first order difference equation, okay? Now, why cobweb? Let me first show you a diagram. So this diagram is showing the time path of price. So this is the equilibrium price. We are finding that the price in the first period, the price is here. Okay, so this movement I have considered first quantity when the price was this. And then we are finding that there is excess supply. Okay, and for that matter, the price will be reduced. However, when it is reducing, it is coming below the equilibrium. So there is an excess demand. Price will go up. When it is going up, it is coming above the equilibrium. Excess supply, it will go down. So price is going down, no doubt. However, it is coming below the equilibrium. Again going up because excess demand. So in this way, it is coming towards the equilibrium E. Actually, the circle is becoming reduced, and finally, the situation will converge towards the equilibrium price level, or towards the equilibrium E. Okay, and it looks like, a cobweb, isn't it? When we are considering different possible levels of price, it looks like a cobweb. It looks like a cobweb or not?
Yes, ma'am.
Yes, ma'am.
Yes,
So
ma'am.
that, this model is called cobweb model. The thing may be reverse as well. So it may happen that in the process, price is continuously moving away and away from the equilibrium. Then also it looks like this. So the previous one was the convergent time path. So this one is the divergent time path. So all possibilities are there. However, when the price is fluctuating, it is moving up the equilibrium, it is coming down the equilibrium, again moving up the equilibrium, coming down the equilibrium, and therefore it is creating the path which is just like a cobweb. Therefore, this model is called the cobweb model. We'll have to find out, derive this model, and understand the nitty-gritties of this model. Okay, so first of all, it's a typical case. When we consider a cobweb framework, it's a typical case. It is applicable for pricing. Here we consider that demand is instantaneously adjusted with price. Demand is instantaneously adjusted with price, that is dt is a function of pt. Demand in tth period is adjusted with the price of tth period. So dt is a function of pt, price at the tth period. However, if we consider the supply context, suppliers take the decision to supply looking at the price of the previous period. But the suppliers look what price I got in T-1th period. So how much I'll supply in tth period. So price in T-1th period determines the supply on tth period. These kind of things happens in agricultural market. Empirically, it was tested, several times. And it is found that in agricultural market, since the commodities are perishable, most of the commodities are perishable, what happens when you are going to the market, you are getting this is today's price and you have to purchase the commodity using today's price. If you think about the vegetables, etc., this is today's price and you have to purchase accordingly. However, the supplier is supplying or decided how much he or she will bring in today's market depending on what price he or she received on previous day. If they find that, the price of, potato, say, was higher in the earlier first day, in that case, how much potato they will bring from the cold storage to the market, that will be decided accordingly. Okay, so for every vegetables and, fruits, etc., generally it is found that suppliers take the decision regarding the quantity supplied for day 2, that is determined by the price of day 1. However, for the demanders, there is no lag in decision making. They are going to the market and whatever price that has been decided in today's market, through whatever mechanism, they have to pay this one. So it's a typical model based on pricing system. or determination of price, where there is one period lag with respect to suppliers. However, there is no lag with respect to demanders. Demand adjusts instantaneously with respect to time, whereas supply faces a lag of one period. So this is our starting point. Any question? Is there any question regarding the agricultural market, etc., etc.? Any question, anyone?
Ma'am, can you explain the demand portion once more?
Yes. Yes, demand adjusts instantaneously, okay? That means for the demanders, it's not that what was the price in day one, on the basis of that, I'll determine the demand, how much I'll purchase from the market. The situation is not like that. For the demanders, they are going to the market, looking at the price, they are deciding how much they will buy. Okay, so you are going to market, you are finding that this particular fruit, the price is 600 rupees per kg. Okay, and then you are deciding how much you will buy. Zero, some positive amount, if that is some positive amount, how much? Okay, so you are going to the market, looking at the price, and then you are deciding whether you will buy this particular vegetable or fruit or you will not. If you buy, what will be the quantity? For the suppliers, they are bringing today's morning vegetables and fruits on the basis of the price they received on the day before. Okay, so there is
Yes.
regarding price and quantity for the suppliers. However, there is no lag between the price and quantity for the demanders. Do anyone have any question? Anybody to ask anything?
Ma'am, so for supply, it's always the price of the time period that is directly preceding the current time period, right? Like it's always the time period that was right before the current time period.
Mm-hmm. Yes.
Okay, okay.
And ma'am, it's always like one period gap.
Yeah,
So
because this is the application of first order difference equation. Okay, so we are discussing some model where the time lag is of one period. If we consider the time lag is of two periods, in that case we have to solve the situation using the second order difference equation. Okay, so when we will discuss second order difference equation, we will discuss several economic applications of the second order difference equation too. So now we are concentrating only on the first order difference equation. So the time lag we will consider that is a lag of one period. Okay.
yes, ma'am.
Okay, so let's start. And for that matter, basically when we will proceed, you will understand. Therefore, this cobweb kind of model is also called the lagged adjustment model. Okay, lagged adjustment model. So as I mentioned in first day's class, please sit with pen and paper. And it is always better for the Matheco classes, at least do some steps so that you really understand the matters. Okay, so you don't need to write let the supply function be. You will get the record, you will get everything. However, please write the supply equation, demand equation, etc., so that you understand the essence of the entire thing. So let the supply function be st is equal to alpha 1 plus beta 1 pt minus 1, where alpha 1 and beta 1 are the parameters of the model. ST, you are understanding, it is quantity supplied at tth period. And it is a function of price of t minus 1th period. It is a function of price of t minus 1th period. So we are finding a lagged adjustment. The supply of tth period is adjusted or determined by price of t minus 1th period. We are calling this equation number 1, and from your previous semester, you know this alpha 1 is nothing but intercept of the supply curve, whereas beta 1 is the gradient of the supply curve. And in a standard case, generally, we find that alpha 1 and beta 1 both are positive in case of a supply equation. Okay. However, rest of the things are also possible because you got negatively sloped supply curve too. Standard case considers beta 1 to be positive. Okay. However, it can be negative as well. No problem. The second equation is the demand equation. dt is equal to alpha 2 plus beta 2 pt. Alpha 2 and beta 2 are parameters. Alpha 2 is the intercept, whereas beta 2 is the gradient of the demand equations. dt is quantity demanded, and we are finding that there is no lagged adjustment between the quantity demanded and the price. Quantity demanded is instantaneously adjusted with the price. dt is a function of pt. So the things can be written in this way, that is, supply responds to the price with a lag of 1 period, but demand responds instantaneously. Okay. So is there any question regarding the structure of the model? And the first sentence.
Ma'am, B is, you said B is the gradient, so is the gradient and slope the same thing?
Yeah. Gradient and slopes are the same thing, yes. Okay. Slope means gradient, tan theta, okay. So tan theta determines the gradient of the equation, which is equivalent to slope of the equation. Okay. Okay, so this is our starting point. We have a demand equation, we have a supply equation. Supply equation has 1 period lag, whereas demand equation has no lag. dt is a function of pt. Next, price will rise or fall in each period t to equate demand with supply. Always, this is the market mechanism. If there is an excess demand, price will go up. If there is an excess supply, price will go down, you know. So if, suppose, let's consider day 1. In day 1, if the system or the market finds that there is a huge demand for a particular product, in that case, in day 2, there is a chance that price will go up. If we find that demand is not that much for this level of price, you know, in that case, next day price will go down. Okay. As price goes down, if we find that demand is again sufficiently larger than supply, price will go up next day. So if you consider this kind of time-based analysis, you know, if there is excess demand, price will go up every time point, at every time point, you know, that time point may be 1 day, 1 week, 1 month, 1 year. Okay, depending on the variable, you will have this kind of thing. However, if there is an excess demand, we know that if d by dp is greater than 0, always there will be an upward pressure to the price. Okay, so price will go up, alternatively go down. Now, actually, if you think a while, time series or time-based analysis is nothing but a bunch of several cross sections, because You are observing period 1, period 2, period 3, period 4. However, you are just not looking at period 3, or you are not just looking at period 1. You are continuously looking at period 1, period 2, period 3, 4, 5, 6, etc. Okay? So whatever principle of adjustment of economic variable we discuss for a particular cross point, that is also applicable for the time-based analysis. What is happening? If I find excess demand in a cross-section analysis, we know the next period price will go up. However, we cannot draw the entire time path because we are discussing a static situation. Okay, we are considering price at a particular time point, and we understand if there is an excess demand, there will be price rise. If there is an excess supply, there will be a price fall. However, when you consider the time-based analysis, this moving up, going down, moving up, going down, this entire picture you get. Okay, so whatever principle we discussed about the cross sections or the static equilibrium or stability of static equilibrium, everything is applicable here. It's a broader context. We are not only considering one particular time point, rather we are considering several time points to draw the entire path or to frame the idea of entire path. Okay, so this is the difference. Okay, so price will rise or fall in each period T to equate demand with supply, because this is the nature of the market. Okay, so finally, the movement of the prices we will get to equate dt with st. Now, we have considered a particular form of dt and st. So, we are equating alpha 2 plus beta 2 pt with alpha 1 plus beta 1 pt minus 1. Okay. Now, would you please write down these two equations first? dt is equal to st. I hope everybody wrote these two equations, 1 and 2. You did it?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Then you write down dt is equal to st, and
Yes,
then
ma'am.
only put the values for dt and st. In the next step, what I am doing, I am keeping pt and pt minus 1 to the left and bringing the parameters where there is no pt to the right. So the elements where we have pt, pt minus 1, all these things we are keeping to the left. The constant terms we are keeping to the right. Now, why we are proceeding in this way? Because we know we have to derive the time path of price using the first order difference equation framework. And therefore, we need to find out the complementary function, we need to find out the particular integral, etc. Now, if I consider the complementary function, that I'll be able to derive only for the homogeneous form of the equation. Now, what is the homogeneous form of the equation? Where in the left-hand side, we will have all variable components, whereas in the right-hand side, we will have the value to be equal to 0. So, in the homogeneous form, there will be no constant in the model. So, all variable terms in the left and right-hand side is only 0. So, this is the shape of the homogeneous form. Therefore, we have to keep the constant terms to the right and all variable terms to the left, so that later on, comfortably, we can write the homogeneous form of the equation. Everybody got my point, or should I need to repeat it?
No, ma'am, we got it.
Yes,
Okay.
basically.
Yes, ma'am.
So voice is not clear. So I'm proceeding. Okay. So later, if anyone has any problem, I'll again clarify the things.
ম্যাম আরেকবার এই জিনিসটা রিপিট করবেন?
Acha. Um, I hope you are understanding this equation. There is no problem in writing this equation. However, the question is why we are putting all pt minus 1 to the left and all the constants to the right. There is a purpose. Actually, this is a first order difference equation. Actually, we need to find out the first order difference equation. Then we have to solve it. So when we will solve it, we need to write the complementary function. We need to write the particular integral because time path will be finally CF plus PI. So if I need to solve for PT, PT is nothing but CF plus PI. Now to derive CF, we need to consider the homogeneous form of the equation. We talk about the trial solution only for the homogeneous form. So if I need to talk about homogeneous form, we have to keep the constant terms to the right and all variable terms to the left so that in the next or next to next step, comfortably we can present the homogeneous form of the equation for which we will consider the trial solution a b to the power t. So if we look at previous days context, we did the same thing. We started with an equation, okay, and when we started to write the equation for the homogeneous form, etc., you will find that no constant term is there to the right. The right hand side is equal to 0 and all variable terms, yt plus 1, everything is to the left. And here yt plus 1 has been replaced by ab to the power t, ab to the power t plus 1, etc. So look at this equation. This is the homogeneous form of the given equation. Yt plus 1 minus 5yt is equal to 0. So all the constant terms you have to keep to the right, and then for the homogeneous form, you have to consider this constant to be equal to 0. So the same thing I am doing for the covered model. I am keeping all the constants to the right first, and then I'll put the value 0 to the right. I'll not write any constant to the right because I need the homogeneous form of equation number 3. So is it now clear?
Yes, ma'am.
Okay. So next what I did, I divided both the sides by beta 2. Okay, I'm writing pt minus beta 1 by beta 2 pt minus 1 is equal to alpha 1 minus alpha 2 to the divided by beta 2. This previous equation is similar to this one, equation 3 and the equation which I have written in this step. These two things are similar. This is the neat presentation of the thing. Okay, generally when we write the first order difference equation, we generally put the value 1 with the highest order variable, and then after that the coefficient starts. This is only the style of writing, So we could work with this or we can work with this. This is the neat presentation, and therefore we prefer to bring, or we prefer not to keep any constant term along with the highest order variable. Okay, next what I have done, without losing any generality, I advanced the time by 1 period. So please note down, without losing any generality, we may advance the time by 1 period. We may adjust the time by 1 period. Okay, that is t will become t plus 1 and t minus 1 will become t. Now why we do that, or why we prefer to do that? Now if there is any t minus 1 is there, when we will consider the initial time period, that is the 0th time period, you will get one p minus 1 time period. That means historical period, or your first starting point, which you are considering to be 0th one, before that there is another time point. However, you do not have any data, any information for that period, because your analysis is starting from the historical point or the first point. Okay, 0th point. As if beyond the 0th point we are not interested for the research, or to the left of the 0th point we do not have any data or information. So to remove this complication, that is our starting point will be 0, then there will be again a minus 1th period, we advance the time by 1 period without losing any generality. We advance the time by 1 period. Okay, so without losing any generality, without losing any essence of this model, we can rewrite the model as pt plus 1 minus beta 1 by beta 2 pt is equal to alpha 1 minus alpha 2 by beta 2. Okay, so I hope you have added the point without losing any generality. We can advance the time by 1 period. And I hope you understood the reason why we are actually doing so. So the model can be safely written as pt plus 1 minus beta 1 by beta 2 pt is equal to alpha 1 minus alpha 2 by beta 2. We are calling it equation 3a because it is not a different equation. So it is not equation number 4, rather it is equation number 3a. This is a first order difference equation in PT. This is a first order difference equation in PT. Why it is a first order difference equation? Because there is 1 period lag in our analysis. Okay, if we increase the lag, in that case we have to move for higher order difference equation model. For this particular context, we are considering the first order difference equation model, 1 period lag. So we need to present the first order difference equation in PT. The concerned variable is PT here. So we need to find out the time part for PT here. So this is a first order difference equation in PT. Any question up to this? How we are framing the first order difference equation in PT? Any question?
No, ma'am.
Ma'am, about the starting point, ma'am, when the first price is P0, so there is some demand, but there is no supply. So you are talking about that period as -1.
I didn't get your point. Would you please repeat it once again?
Ma'am, I am saying at P is equal to 0, ma'am, you took this +1 here because at T is equal to 0, there is some demand but no supply because of lagged adjustment.
No, that will be not the case, Time period is 0. Okay. And there is, so there will be a market price, in when there is a demand equation and there is supply.
Ma'am, there will be market price, but there will be no supply. I'm talking about that.
When T is equal to 0, you are asking?
Yes.
The model is P1 minus beta 1 minus beta 2, P0. P0 is the historical time, So when you are going to the market, already demand and supply are there. The issue is the supply is adjusted following the previous period's price and demand is adjusted instantaneously. But it is not that there is no supply. Okay, so the concept is not like that. So the equation will be P1 minus beta 1 by beta 2 P0. So there is a price for the P0th period is equal to alpha 1 minus alpha 2 beta 2. There will be a problem like that. If I keep the model like this, in that case, it will be P0. However, it will be P minus 1. So for P minus 1, in this supply equation, I have no information. For P0th period, I have information. However, for P minus 1th period, I may not have any information, or there is data, however, that is not my research interest. Okay, therefore, I advance the model by one period so that we do not face any problem. However, the way you are thinking, that is not right. We have to start with a market concept here. Okay, so individually we are thinking about demand, individually we are thinking about supply. It's not so. If I want to frame a cobweb model, I am in a market where there is both demand as well as supply. Okay?
Ma'am,
Yes, ma'am.
Yes.
in equation 3, when we are taking t is equal to 1, we're getting pt minus 1 to be 0. So that is
I didn't talk
possible.
about t to be equal to 1. I just talked about if t is equal to 0. From,
Okay, then that is not possible. Okay.
okay, where to start? For
Yes,
each
ma'am.
of us, it is absolutely fine. Okay. Generally, conventionally, we consider the starting time as 0th time rather than first period. Okay, if you consider the first period is your starting point, then there is no issue. It will be P1, PT will be replaced by P1 and it will be replaced by P0. Then the question is, if you start with the first period, from where you will get the information for the 0th period? So every time you will face this question. Do you really have data for the period which is back to the concerned year? Okay. Got the point?
Yes, ma'am.
Yes, ma'am.
So next I am going for the solution part. First, I'll find out the intertemporal equilibrium price, which is also equivalent to PI, particular integral. Last day we found that. Okay, so for an equilibrium price, we set PT plus 1 is equal to PT is equal to PE. Call it equation number 4, where PE is a constant since PE is a constant since equilibrium price remains stationary over time. Whatever the notion about equilibrium price we have in our mind, that is the equilibrium for all the periods. Okay, so if we think that price 20 per kg is an equilibrium price, in that case, whether we are considering 1998 information or 2008 information or 2018 information, 20 per kg is the market clearing solution, where there will be no excess demand or excess supply. So it is the notion of intertemporal equilibrium. Hence, the equilibrium value is always a constant, a fixed value over time. So we are setting PT plus 1 is equal to PT is equal to PE to get the equilibrium. And then you derive P, plug these 4 in equation 3a and find out PE. Derive it on your own.
Ma'am, can you show me the slide once again?
I think you have written it. If not, please do it. You don't need to see the slides.
I'm done.
Value?
Yes, ma'am, done.
Yes, ma'am, done.
Ma'am, it's done.
Anandarupa, are you there?
Yes, ma'am, I'm doing it. Give me just a few more minutes.
So complete it first and let me know what is the value you are getting. You have to be a bit faster, because presentation, Viva, everything is a part of a CBCS course. I hope already you experienced all these things. So Anandarupa, now you got it? So what is the value? Just a minute.
Ma'am, I'm not sure, but ma'am, is it alpha 1 minus alpha divided by beta 1 minus beta?
Yeah,
The P
just
value.
repeat it once again.
Ma'am, ma'am, mine is coming alpha 1 minus alpha divided by beta 1 minus beta.
Everybody got this value?
Ma'am, we are getting alpha 1 minus alpha 2 over beta
Yes.
2 minus beta 1.
And beta 2 minus beta 1.
Yes, ma'am.
This will be the value. Okay. Alpha 1 minus alpha 2 divided by beta 2 minus beta 1. Okay.
Yes, ma'am.
So everybody please check. Those who wanted to see the slide once again, look at equation number 4. Look at the matter how we are plugging equation number 4 to equation 3a. Then we are solving for PE. So PE is alpha 1 minus alpha 2 divided by beta 2 minus beta 1. This is the value. This is equation number 5. So this is the intertemporal equilibrium price. This is also the value of particular integral. What I told you, equilibrium is equivalent to particular integral. So this is the value of the particular integral. Okay, so one part is complete because when you need to find out the time path PT, in that case you need to derive CF and PI. So you got one thing, PI is now in your hand. So next you have to find the complementary function part. So to get the complementary function part, we have to consider a trial solution for the homogeneous form. So let Pt is equal to AB to the power t be the trial solution for the homogeneous form of 3A given by Pt plus 1 minus beta 1 by beta 2 Pt is equal to 0. Look at 3A. 3A was Pt plus 1 minus beta 1 by beta 2 Pt is equal to alpha 1 minus alpha 2 by beta 2. So the left hand side will be as it is. In the place of right hand side, we are putting the value to be equal to 0. This is the homogeneous form. So Pt is equal to AB to the power t be the trial solution for the homogeneous form of 3A given by Pt plus 1 minus beta 1 by beta 2 Pt is equal to 0. And I'm calling this equation equation number 6. Now from your previous experience, if my trial solution for Pt is equal to AB to the power t, for Pt plus 1, that will be AB to the power t plus 1. Everybody, any doubt? Pt
No.
plus 1 can be written as AB to the power t plus 1?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so put both AB to the power t and AB to the power t plus 1 in the homogeneous form, equation number 6. Thus, please write down thus. Equation 6 can be rewritten as, equation 6 can be rewritten as AB to the power t plus 1 minus beta 1 by beta 2 AB to the power t is equal to 0. AB to the power t plus 1 minus beta 1 by beta 2 AB to the power t is equal to 0. Everybody got it?
Yes, ma'am.
Yes, ma'am.
Then take
No,
AB.
can you please repeat?
Who is this person?
Ma'am, Udita.
Huh?
Udita.
Udita. Udita, what is the problem? You know, Pt is equal to AB to the power t. And Pt plus 1 is AB to the power t plus 1. You got this point?
Yes, ma'am.
So put these two things in the equation.
Okay, yes, got it.
Don't be so shaky. Be bold. Okay. First semester is gone. Now it is the second semester. You should be desperate. Desperately do whatever you can do. You know everything. Please keep confidence in yourself. So it is AB to the power t plus 1 minus beta 1 by beta 2 AB to the power t is equal to 0. And then I am telling you to take AB to the power t common. Take AB to the power t common. Shogata? Shogata, are you there? সৌগত কি পালিয়েছে না আছে? No, সৌগত। অয়ন?
Yes, ma'am.
So you took AB to the power t common?
Yes, ma'am.
So when we are taking AB to the power t common, what will be the form? What will be the shape of the equation?
A b to the power t into b minus b1 by b2. Beta 1 by beta 2.
B minus beta 1 by beta 2 is equal to 0.
Yes, ma'am.
Very good. Now AB to the power t cannot be equal to 0. So we have to set b minus beta 1 by beta 2 is equal to 0. And from there we are getting the value of b, which is equal to beta 1 by beta 2.
Yes, ma'am.
Yes.
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 Yes, ma'am.
Yes.
Yes, ma'am.
So for when I took the trial solution, here A is an arbitrary constant to be determined from the initial condition. You know that. Later we will determine A from the initial condition P naught. Then from 6 we get AB to the power t plus 1 minus beta 1 by beta 2, AB to the power t is equal to 0. Take AB to the power t common, then b minus beta 1 by beta 2 is equal to 0. And from there, b is equal to beta 1 by beta 2, as AB to the power t cannot be equal to 0. Please do all these steps, and if anyone has any question, please ask me.
Ma'am, what is it written from initial condition?
Initial conditions.
Okay, okay.
Done?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am, it's done.
It's done. Very good. Hence, the complementary function becomes CF is equal to A beta 1 by beta 2 to the power t, which is equation number 7. The general solution for the time part of price is given by Pt is equal to Cf plus Pi, complementary function plus particular integral. Now the complementary function is A beta 1 by beta 2 to the power t. So far we could solve up to this. So it is A beta 1 by beta 2 to the power t plus Pi. Pi already we found, which is the equilibrium price, which is alpha 1 minus alpha 2 divided by beta 2 minus beta 1. This is equation number 8. So almost we are done. We got the time path of price. Only one unknown component is there, and that is capital A. So we have to solve for this A. We have to find out this A. Now to determine A, we set t is equal to 0, as we did in the last class for the first order difference equation, so that P naught, P0 is equal to A beta 1 by beta 2 to the power 0. Something to the power 0 is equal to 1. So A plus alpha 1 minus alpha 2 divided by beta 2 minus beta 1. And from there, we are getting the value of A, which is equal to P naught minus alpha 1 minus alpha 2 divided by beta 2 minus beta 1. In other words, A is P naught minus PE, because alpha 1 minus alpha 2 divided by beta 2 minus beta 1 is nothing but PE. Could you write up to this? P naught is equal to A plus alpha 1 minus alpha 2 divided by beta 2 minus beta 1?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
So A is equal to P naught minus alpha 1 minus alpha 2 divided by beta 2 minus beta 1. Or A is P naught minus P, which is equation number 9. Hence, equation 8 can be rewritten as Pt is equal to P naught minus Pe into beta 1 minus beta 2 to the power t plus Pe. Equation 10, and stop there. Don't write the next part. Equilibrium is stable. Stop with equation number 10. You write equation number 10, then it's fine. Just after writing equation number 10, please write down, this is the required time path of price. This is the required time path of price. Done?
Yes, ma'am.
Everybody could do up to equation number 10, and after that just one sentence, this is the required time path of price.
Yes, ma'am.
Yes, ma'am.
So
Ma'am, can you show the slide again?
who is there? Who is this person?
Ma'am,
Continuous.
this is Joanna.
Juina, what is the problem with you? Which part you could not write?
Ma'am, the last equation. I cannot write it down.
So do it on your own. Okay.
Okay, ma'am.
And to do that,